Okay, guys, so today we'll be talking about graphing logarithmic functions. Okay, and to start off, it's important to remember what exactly a log is. So let's start off with 3 squared equals 9. And obviously, that's a true statement. 3 times 3 is 9. Okay, and so if we write that as a logarithm, we can say log base 3, and then parentheses next to it, we'll write our answer, which is a 9. And then that equals our exponent, which is a 2. Okay, so we can say 3 squared equals 9. As a logarithm, is log base 3, 9 equals 2. And one way to remember it is just 3 to what power is 9? Well, 3 to the second power is 9, or 3 to the second power is 9. Okay, so a logarithm, once again, just solves for an exponent. Okay, so what exponent do I need to put on a 3 to get out a 9? That's obviously a 2. Okay, so let's say then I have log base 2 and then x plus 1. Okay, so what I'm asking here is 2 to the what power? I'll say 2 to the what power equals x plus 1. And I can plug in any value for my answer over here because I have a variable inside my parentheses. So whatever I want my log to equal, I can just set my x plus 1 equal to that. Okay, so if I have log base 2 x plus 1, I can say it equals 0. Okay, because 2 to the 0 power is 1. Anything to the 0 power is 1. Okay, so here 3 to the second power is 9. 2 to the 0 power is going to be 1. But x plus 1 is there. So that means that x plus 1 must equal 1 for this to be true. So to solve for x, I can say minus 1, minus 1. So x equals 0. So at x equals 0, my logarithm equals 0. So if I make an ordered pair, I have x equals 0 and my logarithm equals 0. So I have an ordered pair at 0, 0. Okay, well, the same thing, another easy one we can use is I can say log base 2 of x plus 1 equals, let's say it equals 1. Okay, so once again, I have 3 to the second power equals 9. So here I have 2 to the first power equals x plus 1. And 2 to the first power is 2. Anything to the first power is just itself. So I can say that x plus 1 equals 2. Because if 2 to the first power is x plus 1, 2 to the first power is 2. So x plus 1 must equal 2 if my logarithm is going to equal 1. Okay, so solve for x, subtract 1, so I have x equals 1. So when x equals 1, y equals 1. So I'll have an ordered pair at 1, 1. It doesn't always work out this nicely, but that's pretty convenient for our first one of the day. Okay, so now if I'm going to graph this, remember all I really need are 2 points and an asymptote. I'm only going to take it out to the 2's because that's all I really need. Okay, so remember, my h value, which is right here, this is my h value, that is always going to be my vertical asymptote. I do not care what's out in front. I don't care if anything else is inside with my x minus h. My h value is always my vertical asymptote. Remember, it's going to be the opposite because my formula says x minus h. So I'll have a vertical asymptote at negative 1. Okay. Now I have a point at 0, 0. And I have a point at 1, 1. And that's plenty to determine what my graph looks like. Just like that. And I have no negatives here or there. So I know that I'll have a regular log function that goes up and to the right. Okay. So let's try one more. And let's make this one a little bit more difficult. Let's say f of x equals -2. Let's make this just log, and then -2 inside, x minus 3 plus 1. Okay, so this looks like a mess, but we can make it work just as easily as the last one if we just remember what we're doing. So I'm going to go ahead and draw my graph here, coordinate plane. Okay, so first off, remember, no matter what's here or what's there, okay, I know it looks different, but all I care about is my h value, which is right here. That will always be my vertical asymptote. Remember, it's always the opposite. So have vertical asymptote at +3 right there. Okay, well, once again, if I set my logarithm equal to 0, right, just like we have up here, if I set it equal to 0, that tells me that my parentheses must equal 1, okay? Because, and once again, if I don't have a base under my log, just know it's a 10, log base 10, okay? So, just like I have up here, 2 to the 0 power equals 1. Same down here, 10 to the 0 power equals 1, but it also equals -2 times x minus 3. So if -2 times x minus 3 is equal to 1, I can say that -2 times x minus 3 equals 1. Okay, I can divide by -2. So I'll have x minus 3 equals -1/2. Can add 3 to both sides. So I'll have x equals 2.5. So that's the first half of my ordered pair, 2.5. And when my logarithm, or what's inside my logarithm, equals 1, that means I raised my 10 to the 0 power, which means my logarithm equals 0. And since all of this is now equal to 0, 0 times -2 is 0, and 0 plus 1 is 1. So I have my y-coordinate at 1. Okay, and I can go ahead and graph that. Okay, so I'll be at 2.5 and +1. And based off of my negative values, this negative tells me I'm going to flip it over the x-axis. So I'll be facing downwards. Okay, and then this negative inside tells me I'll flip it over the y-axis. So based off these two negatives, I know that I'll be going down and to the left. Okay, and this vertical asymptote here with my point on the left side tells me I'm on the right track so far. Okay, so now, just like we did up here, once again, if 2 to the first power equals x plus 1, then x plus 1 must equal 2. So, same way down here, if -2 to the x minus 3 equals 1, then -2 to the x minus 3 must also equal 10, because 10 to the first power equals this. So, just like I did over here, I will set it equal to the base, which in this case is 10. Okay, once again, I'll solve for x. So x equals -2. That's the first half of my ordered pair. And then remember, 10 to the first power equals 10. So my entire logarithm now equals 1. And 1 times negative 2 is negative 2, plus 1 is negative 1. So I have my other point at negative 2, negative 1. Negative 2, negative 1. 2 asymptotes and a point, or 1 asymptote and 2 points. Gives me plenty to graph my line. And as you can see, just like we predicted, we'll be going flipped over the x-axis. So I'll be facing downward, be going down. And my negative inside tells me I'm going to the left. Okay. So, short and simple, set your inside parentheses equal to 1, because anything to the 0 power equals 1. Okay, so if we can make my parentheses equal to 1, that tells me my logarithm equals 0, because your logarithm solves for your exponents. Same way, if I can set my parentheses equal to my base, anything to the first power is itself. So if I can set my parentheses equal to my base, then my entire logarithm equals 1. Both of those are pretty easy to solve for and understand what's going on. So those are two very easy points to solve for on my logarithm. My vertical asymptote always stays the same, no matter what kind of mess is up here, no matter what mess is over here. Don't care. My vertical asymptote is always that point right there. Remember, my formula is x minus h. So your h value will be the opposite. So if it has a minus 3, it's just a positive 3, just like we've done here.